Hello everyone. So previously we had discussed on the topic circle line as well as the circle intersection algorithms. Yeah. So today we'll be going with the Voronoi diagrams as well as this one and Delaunay triangulations. Right. So let's see what the definition part says here. Voronoi diagram. So it divides the plane into regions. What it does, it divides the plane into regions based on the distance to set a given point each region. To set the given point each region contains all the points closer to one specific seed point, right? Contains all the points closer to one specific seed point than to any other. Now let's move on with the second one, nothing but Delaunay triangulation, right? So it connects a set of points, similar one. It connects a set of points into the triangles, so that no point lies inside the circumcircle, right? So that no point lies inside the circumcircle of any triangle, minimizing the this one minimum angle of all the triangles, right? So that's what Delaunay triangulation does. Now let's get into the explanation part. One simple one. So see here. So imagine let's imagine we drop a stones on a flat surface, right? So we have a flat surface, and suppose if we drop a few stones on the flat surface, a Voronoi diagram shows the surface gets divided into territories. Yeah, surface gets divided into the territories, and each stone closer areas belong to that stone, right? Each stone closer this one around each stone. So this one a Voronoi diagram shows the surface gets divided into the territories around each stone. Closer areas belong to that stone. Yep. What does the Delaunay triangulation does then? It connects the stone into lines, right? It connects individual stones from one stone to another. It connects the stones with lines to form the triangles in such a way that no stone falls inside the circle made by any triangle, right? So let's see these two things in the action. So these two are dual of each other, right? These two are dual of each other. If you have one, you can derive the other, right? So if you have one, you can derive the other. So let's start writing the code, or let's start with the algorithm. So we will be making use of three libraries here. One is NumPy, and another one is SciPy, and the third one is this one, Matplot actually, right? So these three things. First, I'll do one thing. Let me go with import NumPy as NP, right? So the second one here, let me go with import SciPy. Mm, I'll just go with SciPy.spatial here, right? I'll just go with, yep, spatial. So let me import certain things actually. Let me import Voronoi actually here. What's wrong here? Statement must be separated by new lines or semicolons. But hmm, 1 second. Oh, okay. I have given import here instead of from. So let me change this one to from. Yeah, sorry. From. So now let's go with Voronoi. Also let me go with, yeah, Delaunay. Yep, Delaunay. Yep. Let me choose this one. Next, let me go with import here matplot. So yeah, matplotlib. So I'll just go with pyplot here, right? So dot pyplot as VLT. So this is fine. Yep. Next, what happened here? Import could not be resolved from the source. So yeah, let me install this one. Just give me a second here. So I'll just give here pip install matplotlib. So just give me a second here. Let it get installed. Actually. So then the error should get this one resolved actually. Yep. So here, you can clearly see here, this got installed, right? So this is fine. Mm, keep clear screen here. Yep. Now we can make use of this one, right? So let me close this one. I can just make use of this one, matplot library now. So first, let's create the random points, right? So I'll just go with the points equals np dot. I'll just go with the random here dot array nd. So this is not showing. Why? What happened? What's wrong? This is quite slow actually. Yep. So I'll just go with 10 comma 2 here, right? So this is fine, man. Next, after creating the random points, let's create the Voronoi diagram, right? So I'll just go with a variable vor. So this is fine. Let me pass Voronoi here. Yep. So this is fine. Of let me pass points. So this has to show. Yep. This is fine. So the next step after creating the Voronoi diagram, so we have to create the Delaunay triangulation as well, right? So I'll just go with a variable tri here. Let me go with Delaunay of points, right? So let me pass the points here. Right. So I'll just give me a second here. The next step would be, fourth step would be, we have to plot both the diagrams, right? So I'll just consider the variable fig as well as ax here. So let me assign this one to plot dot. I'll just go with the subplots here. This has to show, yep, subplots of, let me pass here 1 comma 2. Let me go with a figure size here, nothing but fixed size. I'll just go with fixed size here. So this one, let me pass 10 and 5 respectively, 10 and 5 respectively. Now what we have to do, we have to plot the Voronoi, right? So I'll just go with ax of 0. This is fine. Dot, let me go with a set title. Let me go with set title of Voronoi diagram, right? So I'll just go with diagram. So this is fine. Yep. So let me do one thing here, capital D. Yep, let me go with the capital D, and let me go with the ax of 0 here. Dot, let me go with the plot here. So this is fine. So within this, let me pass the points 0. Yep, so this has to work. I have to give comma here, I believe. Else we'll be getting there. Yep, so this is fine, I believe. Next, what we have to do, we have to go with 0 to 1, and let me go with points to 1 actually. Yep, so this is fine. I'll just go with a KO here. Right, so this is fine. KO is nothing but the black dots for the points. Yeah, don't get confused here. So let's move on with the for loop, man. For individual region, so I'll just go with for individual region, and VBOR is the variable that we consider for Voronoi diagram, right? So I'll just pass the regions here. Yep, so this is fine. So within the for loop, first thing, let me go with if not -1, this one region, this has to show, not showing. Anyways, let me type this one entirely. -1. Oh, I have to mention in here. Okay, now this error has to. Yeah. Uh, and let me go with length of region, right? I'll just go with length of region. If it is greater than 0, if it is greater than 0, I'll go with polygon. Let me go with polygon equals, this one will be vivo or dot vertices actually. Yeah, this vertices of I, vertices of I for I in region, for I in region. Yeah, for I in region, I'll just go with ax of 0 dot fill this one. I'll just go with zip, just go with zip star polygon. So let me go with, yeah, polygon. This has to show. Yep. So this is fine. I have considered polygon, right? So let me set the alpha value as well. So let me set the alpha to zero point 0.3, right? So let me set the alpha to 0.3. So this is fine, man. Now what we need to do? So we are done with the iteration part. So this one for loop basically. Now we have to plot the Delaunay as well, right? So we have to plot the Delaunay atomic cost. So how can I write this one, man? 1 second. Yeah, I'll just go with x1 here dot set title. So this is fine. Yep. So let me go with Delaunay triangulation. So this one, where is this one? Yeah. Um, let me copy this one actually, and let me paste it over here. Delaunay triangulation. Right. So this is fine. Yep. The next part, let me copy the same thing, and I don't have to copy, I believe. So this is completely different. Anyways, I'll just go with AX1 here. I'll just go with this has to show try plot, not showing. Let me type this one entirely. Try plot. We have to consider the points here. So points has to show. Yep. Points first. Let me go with a 0 as well as the 1. The same thing that I have written. Yep. Let me copy this one actually until here. Yep. Until or until here. Let me copy this one entirely. Yep. So let me paste it over here. Right. So this one has to be instead of the give within the strings, I'll just go with a triangulation simplices actually. So I'll just go with tri, the variable for the this one, Delaunay triangulation, right? I'll just go with simplices. Yep. So this is fine. Yeah. Right. Try simplices. So this one is fine. X of 1, try plot of 0, we have successfully plotted the Delaunay. So then what we have to do, I'm not able to understand. We have to go with the simplest that gives the triangle, that gives the triangles actually, nothing but the vertex indices, right? So again, uh, so the same thing we have to go with, I think. So this one, let me copy this one entirely. We have to make some changes, but give here x of 1 dot plot instead of x of 0, this is x of 1 dot plot of this one points. So this is fine. 0 point. So this is also fine. 1. Mm, okay. So this is fine. Yeah. Simplicist gives the triangles vertex indices. I believe that that is correct actually. So then we can just go with a if everything goes well. So I'll just go with a plot dot show here. Right. So this has to show. Yeah. We have show here. Let me call this one. So the final step here is we have to print the details, right? So I'll just go with here print. This is just for the interactive purpose, right? So I'll just go with Voronoi, this one, vertices. Yeah, vertices. So this is fine. Let me give slash in here. This is fine. Let me call vivo r is the variable name that we have considered dot vertices. Yep. So this is fine. Next, let me go with print again. So within this, let me go with actually here Delaunay simplices, right? I'll just go with simplices of let me pass the triangles here, right? I'll just go with pass the triangles basically. Make use of the triangles here so that we understand this one clearly, right? So again, I'll just give slash n. So this one will be try dot simplices. Yeah, try dot simplices. Yep. So this is fine, I believe. This is fine, I believe. Yeah. Yep. So this is it for the code, man. So this is it for the code. We have discussed this one step by step, I believe. So let me explain you one more time so that we don't forget this one, right? So this is very important, basically. Let me explain you from the scratch, actually. Yeah. So we have the coding part. I'm speaking of only the coding part. Yeah. So this one. First, we are importing the libraries NumPy, SciPy.spatial, and this one matplot library, right? So NumPy because it handles the numeric data and the coordinate points. So this one I'm speaking of. SciPy.spatial, whatever we have used, this library basically it provides the geometry tools, right? Like Voronoi and Delaunay. So these two things. Again, SciPy.spatial it provides the tools like Voronoi and Delaunay. So the third one, we know this one, matplot library. So this is nothing but it visualizes the diagram, right? So this is fine. It visualizes the diagram. So second, what we are doing here, np dot random dot rand we have made use of here, right? So this one 10 comma 2 whatever I have given. So this one, it is used to generate the points, right? So basically or primarily it creates 10 random 2D points here, right? So primarily it creates 10 random 2D points here. So this is fine. The third one here, the third one, it creates the Voronoi object. It creates the Voronoi object, meaning Voronoi of points. So whatever I have given here, the line number 27, it creates basically Voronoi of points. It divides the plane into regions, sorry, right? It creates the Voronoi object. Next, we are creating the Delaunay, right? Next, we are going with the Delaunay. So here, this is nothing but the TRI. So this is nothing variable name. So this is fine. Delaunay of points forms connected triangles ensuring Delaunay property. So this is fine. Finally, what we are doing, we are moving with the plotting, right? So we are moving with the plotting. So we are going with the first and second plot here, first and second plot here. Then what we are doing, first subplot draws the Voronoi region colored, this one polygons. The second subplot, what it does, it draws the Delaunay triangles using the triplot, right? Triplot actually, this one, first subplot, this one, triplot, sorry. Yeah. So this is fine, I believe. Yeah. So this is fine. The next final one is here. What we are doing, this is fine. Show this is fine. This and all fine. So finally, what we are doing, we are displaying the results actually. Plot.show is nothing but shows both the diagrams. One is Voronoi diagram as well as the this one Delaunay triangulation, and then we are just printing the numerical data of vertices and the triangles, right? So we are just displaying the results. Yep. So what's the output that we need to get here? We are going with a print here. We are going with the Voronoi vertices as well as the Delaunay simplices, right? Nothing but the triangles. Nothing but the triangles. So one is vertices and another one is simplices we have to get here. In this case, let me tell you for the input that we have considered, for the input that we have considered 10, 5 and 10, 2, we have went with 10, 2 and 10, 5. So one second. So the for the Voronoi vertices, actually, we have to get so let me go with here 0.45 1.02 0.45 1.02. So this one will be 0.33 0.11, right? So let's do one thing, rather than this one, let me run the code and explain the output there itself, right? So I'll just do one thing. Yeah, let me copy the entire file name here. Just come and give control J here, Python followed by the file name dot py, right? So let's wait for some time. I'll just give enlarge this one so that this looks good. So I'll just explain you once the output, we get the output actually. So this is taking a lot of time actually. Let's wait for some time. What happened to this one? Yeah, let's wait for some time. Matplotlib, this one lib is building the font cache. This may take a moment. So yep, let's wait for some time. Yeah, you can clearly see here. It is showing the Voronoi diagram as well as the Delaunay, this one, triangulation, right? So this is nothing but, so basically for the Voronoi vertices, you can clearly see here, we are going with the first vertex from 0.45 to 1.02, right? From 0.45 to this one, 1.02, 1.02 for the first vertex, right? So the second one is 0.33 to 0.11, 0.33 to 0.11, right? So this 1.33.11, this 1.33.11, right? So this is fine. Next, we are going with a 0.98 and 0.45, right? So we are just going with a 0.98. 0.98 comes somewhere around here actually. Yeah. So this one, I believe, 0.98 actually and 0.45, right? So 0.45, somewhere it comes between 0.4 and zero point 0.6, right? So I can just consider 0.45 this one vertex, right? So next one, we are getting this one 0.72 and 0.60, 0.72 as well as the 0.60. So 0.72 you can just see here, it comes between this one 0.62 between zero point 0.8, this one actually 0.72, this one, yeah. So 0.7 to 0.60, 0.60, this one exact 0.6, right? So this one where I'm pointing, right? So this is fine. The final one Voronoi this one vertices 0.12 and 0.50. 0.12 actually this one 0.12 before this one 0.2, this vertex, and 0.50 is nothing but the one is middle, so this one I believe, or this one, yeah. The one is exactly this one, it comes between zero point 0.4 and zero point 0.6, yeah. So this is fine. Yep. So these are the Voronoi vertices. And Delaunay triangulation, Delaunay this one triangulation, what it does actually, this connects in the this one in the form of triangles, right? That it connects the stones in the form of triangles. We have discussed this one. The exact same thing, it is shown in the form of diagram here, right? So first thing, 1, 5, 3, right? 1, 5, and 3, right? So here you can clearly see 1, 5, 3. The second one is 3, 6, 9, right? We are going with a 3, 6, 9. For the third one, this one Delaunay triangle, this one Delaunay simplicis, so nothing but the triangle, it is 472. It is 472, and the fourth one is 0, 1, 5. So figure is shown here, right? Figure is shown here. So this is for the Voronoi vertices, and this is for the Delaunay triangulation, right? So, yep, we have got the desired output for the code that we have written. We have got the desired output for the code that we have written. So let me close this one for now. Yep, see, you can clearly see here Voronoi vertices and this one Delaunay simplices, right? So this is also correct. When I ran for the first time, the output that I showed you, that I got that output actually. So this is also the correct output. So one thing I want to tell you is Voronoi and Delaunay, right? Delaunay actually outputs basically differ every run because the input points are randomly generated here, right? So the math and logic, whatever the code that we have written, the math and this one logic remains exactly same. It doesn't differ actually. Yeah, it doesn't differ. In simple terms, Voronoi and Delaunay outputs differ every run because the input points are randomly generated. Just keep this in mind. The math and logic remain the same, but this one we get we just get a different pattern, this one of regions and the triangles each time we run the code, right? So to make our visuals reproducible, we can just set a random seed using np.random.seed of something 42 like that, right? So we can do that one. We are just going with a this one in np.random.rand of 10 comma 2, right? So this differs every time when you run. Yep, the first time that I got, I showed you the output. So but this we got visually, we have seen the diagram as well, right? So both Voronoi as this one Voronoi as well as the Delaunay, this one triangulation. Basically it consists of certain vertices, and here this side it consists of the triangulation. Yep, nothing but the simplices. Yep. So we are done with the this particular algorithm. Yeah, we have got the desired output. We are done with this particular algorithm. So next, before hopping into the next algorithm, and one more thing, we are done with the geometry based algorithms as well, right? So we are done with the geometry based algorithms as well. Further, we'll be moving on with the advanced or miscellaneous algorithms, some advanced or miscellaneous algorithms, right? So whether it may be TREEP, we didn't discuss TREEP, or randomized BST. So we are left with red black tree, we are left with AVL trees, we are left with Bloom filters algorithm, we are left with KD trees, we are left with Morse algorithm on trees, the most important one, right? So we are left with meet in the middle algorithm, we are left with a subset enumeration algorithm. So these are some of the algorithms that are left. Basically, we are left with 8 algorithms, I believe. The last 8 algorithms, yeah. We'll be discussing that one within the advanced or miscellaneous algorithms, yeah. So yep, so this is going to be the last algorithm within the geometry based algorithms playlist, or geometry algorithms playlist, right? So I hope the this one solution part is completely clear, man. Yeah, I hope the algorithm part is completely clear along with the solution part. Yep. uh, so yeah, we are done with this part, right? So let's do one thing before hopping into the next algorithm. So let me summarize whatever we have learned so far, right? So let me summarize whatever we have learned so far. Just give me a second here. 1 second. Did I miss anything here? Right. Yeah. And one more thing, whatever the diagram that we saw, right? So let me run this one again actually. Let me give clear screen here. Yeah, let it take some time. The diagram will pop up. So I just want to tell you here, see, I just want to tell you here, every time the random ones will be generated, right? So based on the algo that we have written. So each row under the Voronoi vertices, each row under the Voronoi vertices, see, shows the intersection points of Voronoi edges. Just remember this one, yeah? And each row under this one, uh, Delaunay simplices lists 3 points, right? Nothing but the indices forming one triangle. Again, each row under Delaunay simplices lists 3 points, nothing but the indices forming one triangle, right? One such example, I have already given you the example 153, maybe this one. It means triangle formed by the points 1, 5, and 3 respectively, right? So this is fine. You can see here this one. Every time if I show here this one, if I hop here, it is showing x comma y 0.341, 0.725. Yeah. If I point here, this shows zero point 0.6, this one 168.594. Yeah. So this is fine. So basically, one of the examples that I gave you is 153 means triangle formed by points 1, 5, and 3. Right. So you can just check, you can just hover on the this one, three vertices, by three vertices, that triangle has been formed on three vertices, right? So this one you can consider, uh, this one 0.420, 0.426. This is also one of the triangle. This one 0.397, 0.862, and this one we can consider. So this is also one of the triangle, right? That is formed. So like that, 153 we can consider, and which means triangle formed by points 1, 5, and 3 respectively, right? So now, again, so we are done with this algorithm. Let me close this one. We are done with this algorithm. And as we are done with this algorithm, let me summarize whatever we have learned so far, right? So just try to remember these 3 or 4 points. These are very important actually. The first one is Voronoi diagram divides space into nearest point regions, right? It divides space into nearest point regions. Yeah, I'll just go with nearest point regions. Yeah, so this is fine, I believe. Nearest point regions. So the first one. What is the second one here? So the second main point here would be Delaunay triangulation connects points into, it connects points into what points into non-overlapping triangles, right? So you saw that one in the figure just now. You saw the Delaunay triangulation, right? It connects the points into non-overlapping, I'll just write here non-overlapping triangles, right? Non-overlapping triangles, right? So let's move on with the third one here. The third one, they're mathematical duals, right? Dual nature, basically. They are mathematical duals, right? Meaning each edge in one corresponds to an edge in the other, right? So this is pure duality actually. Yeah. So each edge in one corresponds to an edge in another, right? So these are mathematical duals actually. Yeah, these are mathematical duals. Each edge in one corresponds to an edge in the another, right? So let's move on with the fourth one here, the final one. Let's discuss the use cases as well. Try to remember this one as well. It is used in computer graphics mainly. Yeah, it's used in the computer graphics. It's used in the geography. It's used in the geography. It is used in the pathfinding actually, and also it is used in the mesh generation. It is used in the generation of the mesh actually, mesh generation, right? So this is fine. So these are some of the points that I wanted to discuss. Yeah, so this is very important, man. Yeah, you have to know this at any cost, right? So this is fine, I believe. Yep, so we are done with the Voronoi diagrams and Delaunay triangulations algorithm, right? So next, also we are done with the geometry algorithms playlist, right? So this is going to be the last algorithm, as I've said, within this particular playlist, geometry based algorithms playlist. Next, we'll be starting advanced or miscellaneous algorithms playlist, and within that, the first algorithm that we'll be starting is TREEP, or the randomized BST, right? So for now, this is it. Thanks for watching, guys.